Let's take a look at basics of functions and their graphs. And let's look at a definition of a function. For a function, goes like this. For every x there is only one y. So for every x, there's only one y. Let's look at our first problem here. It says determine whether each relation is a function. We got 3, 5, 4, 7, and 9, 9. So basically given 3 points. Let's create a mapping on this. So I'm going to put my x values here, I'll put my y values here, and I'm going to write down my x values from smallest to largest, not repeating any. So I got 3, 4, and 9. And then I'll write down my y values from largest or smallest to largest, not repeating any. So we've got 5, 7, 9, and I'll circle each one of these. Now this first point, 3, 5, that maps 3 to 5. So I'm going to draw a line between them. Then 4, 7, that maps 4 to 7. And then 9 and 9, I'll draw a line from the 9 to the 9. For every x, there's only one y. Graphically, if you look at this, if you only have one line coming out of each x value, then it's a function. So this particular one is a function. Let's look at another example. We're given the points 5, 3, 5, 4, 6, 3, and 6, 4. Same instructions, determine whether each relation is a function. Again, I write down my x values, not repeating any. So I got 5 and I got 6. And I write down my y values. I got 3, 4, 3, 4, so I got 3 and 4. Draw a line between them. 5 maps to 3. 5 maps to 4. 6 maps to 3. And 6 maps to 4. Okay. For every x, there's only one y. Well, on the 5 and the 6, I see there's 2 lines coming out of both those numbers. So this is not a function. Well, that's the graphical way of viewing that. There's an easier way. If you see your x values repeat, it's not a function. See how my first problem here at 3, 4, 9? They didn't repeat, did they? So that's a function. But down here, we had 5 and 5. Those both repeated. So right there, I can stop and say that's not a function. So much easier than drawing the picture here. I always draw the picture, though, because for those going to elementary education, a big part of that is graphically representing items. People through, well, I shouldn't say K through 12, maybe K through 6. They think better in terms of that than abstract thoughts. You draw them a picture, they can see it better. So again, just to illustrate that, let's take a look at our third example. We'll use a shortcut on this. So we've got 2, 1. 3, 1, and 4, 1. Now using that little trick I just said, see our x values, we got 2, 3, and 4. They don't repeat, do they? So this is a function. Now it doesn't say anything about your y values. See how these are all 1s? The y values can repeat. All we're saying is the x values can't. For every x, there's only one y. It can be the same y, but for each x, there's only one. Well, this is almost an impossible definition to work with. If you start looking at harder problems, for example, if I have y to the fifth minus y to the third plus square root of x minus x squared equals 7 minus y, and the question is whether it's a function or not. Well, for every x, there's only one y. Well, I try it. I try an x value. I plug in x equals 1. Solve this down, get the y value. And it works. It works. Only gives me one answer. I plug in x equals 2. Work the problem down. X equals 3. And go on. I could actually spend the rest of my life working this problem and still not know whether it's a function or not. Really, it only works when you're using that definition above if you can actually think of a number that will give you two different y values. Well, let's look at an easier way to determine if something's a function. Now, this easier definition, I'd say works 100% of the time in college algebra, intermediate algebra. You start going up in some of the harder topics like calculus, it'll probably start failing a certain percentage of the time. An easier definition. If you have one of the following, so if you have one of the following, it is not a function. If we have y squared, if we have y to the fourth, or if we just have y to an even power. If you have the absolute value of y. If you have a plus or minus square root of x. Now, this doesn't say that you can't have a positive x, square root of x, or you can't have a negative square root of x. You cannot have this symbol in front of you, square root of x. Or if you just have plus or minus x in some form, that's not a function. If you have x is equal to a number, like x is equal to 3, that is not a function. Now, this is definitely not a comprehensive list. It doesn't include everything. And realize these do not have to be by themselves. We could have y minus 3, all of it squared. But key is you have a y and you have a squared. The absolute value of y. We could have something else in here with a y. We could have the absolute value of y plus 7. But the key is you have an absolute value with a y inside of it. Okay, let's use this definition to work some problems now. Number 4. It says determine whether each equation defines y as a function of x. Actually, before I do that, let's go back up to our hard problem here. The question is if this is a function or not. Well, we have y to the fifth power, y to the third. That's okay. We can't have y to an even power. We have a square root of x. That's okay. We just can't have that plus or minus symbol before square root of x. X to an even, we didn't say anything. And y to the first, we're fine. So this would be a function. Okay, so we got x plus 3y is equal to 4. Again, we're looking for our bad items here. We don't have any y to an even power. Y to the first is fine. X to the first is definitely fine. So this is a function. Our fifth problem here. We got x squared plus 5y is equal to 3. Well, x to a power doesn't matter. Y to the first power, still fine. So that's a function. We have x squared plus y squared equals 16. This is not a function. We said we can't have y to an even power. We have a y squared, don't we? So that's not a function. (5x) is equal to y squared. Again, not a function. We cannot have a y to an even power. this one. We have y is equal to negative square root of x minus 2. And this is a function. It's fine. We said we can have a square root with a negative before it. We just can't have a square root of x of some form with a plus or minus symbol in front of it. Ninth one here, we have 5x plus y to the third is equal to 2. Well, this is fine. We can't have y to an even power. Y to an odd power is fine. Seem to have quite a few of these for some reason. Okay. Got xy minus 3y equals 2. Again, this is a function. We don't have y to the first power is fine. We just can't have y to an even power. And our last one. Absolute value of x plus y is equal to 3. This is fine. We can have the absolute value of x. We can't have the absolute value of y. So this is a function. Now we have something called function notation. And it has two purposes. One is to give an algebraic expression a name. I always give this example in class. I pick on somebody, and I like say I'll refer to the woman in the front row. She's wearing a pink shirt today, and she's got blonde hair. So I say I'm gonna call on her all during the semester. I'm gonna say, okay, a woman with pink hair or pink shirt and blonde hair. What's the answer to this? Or I'd say, okay, a woman with pink blouse, pink shirt, and blonde hair. What's the answer to this? Over and over. A better way for me to refer to her would be her name. So to learn her name. Well, that's the same way here. We have this right here. Y is equal to 3x minus 1. And we want to give it a name. So you might be saying, well, it's got a name. It's y. You know, if you say graph y. Okay, but what if I have another one up here on the board? Y is equal to x plus 2. And then I said, okay, go ahead and graph y. Your question would be, well, which one? Well, we're going to give this one a name. Put this f and then begin parentheses x and close parentheses. This is read as f of x. And that's its only purpose, is to give it a name. And this one we could call g of x. Now it's not g times x, that's just notation. And again, that's read as g of x. Now we get even lazier. Given it a name, we'll oftentimes just refer to that as f, or refer to this as g. So that's its first purpose, give it a name. Let me save this. So basics of functions and their graphs. Actually, I don't think I need to save these. Sorry, I got these saved for these sections. My earlier ones I didn't. So let me just start a new page. Which that makes me nervous not saving it now, but okay. Make a look. Okay, so 2.1, we have our PDFs here. Okay, we're fine. I won't worry about saving it then. Okay, second purpose. Let's take a look at a problem to understand this. We had some problems before in elementary or intermediate algebra, algebra 1, algebra 2. Said evaluate y is equal to 3x minus 1 for y when x is equal to 5. Well, how we do this is we take our y is equal to 3x minus 1, and you replace your x with parentheses, and we plug in 5, and then we simplify it. So we got y is equal to 3 times 5 is 15 minus 1, or y is equal to 14. And that'd be your answer. Well, that's a lot of writing, especially when you can't even read my writing. Let's consider we're using function notation. We say f of x is equal to 3x minus 1. If we have it written this way, that says all those same words. F of x equals 3x minus 1, we want to find an f of 5. Now what we're going to do is we'll do the same thing. We're going to take our 3x minus 1, and where x was, we'll put in parentheses. And then whatever is inside the parentheses right here is automatically what goes in right there. So we put 5 in there. 3 times 5 is 15. 15 minus 1 gives us 14. So you see we get the same answer. It's just a function notation allows us to very easily write all those words in symbols. Let's look at a problem. Evaluating a function. So number 12 here. We got g of x is equal to x squared minus 5x minus 2. And we want to find g of negative 3. Okay, so evaluating a function. Now keep in mind that the number inside the parentheses, or whatever's inside I should say, this is what we are evaluating for. Okay, so step 1. Replace our variables, I should say. Replace our variables with sets of parentheses. Assuming I could spell. Go back to 4th grade. Okay. There, that's better. With sets of parentheses. So we have x squared minus 5x minus 2. So wherever we have an x, we'll put in a set of parentheses. Usually people, when they mess up on these, mess up on signs and so forth. So it's a good idea. First step, just go through and put parentheses wherever you have variables. Then step 2, plug in what we are evaluating for. Into the parentheses. Now again, whatever we have inside the parentheses here is what we're going to put in the parentheses at this point. So up here, we had negative 3 in the parentheses, so we'll plug negative 3 in for the parentheses down here. And then step 3 is simplify. It's kind of vague, but it could be combining numbers, could be doing order of operations, could be items involving x's. Well, negative 3 squared gives us 9. Negative 5 times negative 3 is positive 15 minus 2. That gives us 24 minus 2, which gives us 22. Let's take a look at part B. Part B says find g of x plus 4. See, our original problem was x squared minus 5x minus 2. So again, first step is we're going to go through, and everywhere we have an x, we'll put in parentheses. Now whatever is inside the parentheses here is what we're going to plug in at this point. And it was x plus 4, so I'll put in x plus 4. Now x plus 4 squared, we have to write out as x plus 4 times x plus 4. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20, minus 2. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. Still, writing's sloppy. Not that it's ever good, but negative 5x, negative 20, negative 2 is negative 22. Combine together like terms. 4x plus 4x is 8x, minus 5x gives us 3x. And then we've got 16 minus 22, which gives us minus 6. And that'd be your answer. Now C. I want to find g of negative x. It doesn't matter what's inside the parentheses. It's still exactly the same steps. We're going to go through and replace our x with parentheses. Everything else remains as is. Whatever is inside the parentheses right here is what's going to go in down here. So it's negative x, so we'll plug in negative x. Now negative x squared is a positive x squared. Negative x times negative x. Negative 5 times negative x gives us a positive 5x, and then minus 2. And that's our answer. Let's take a look at another one of those, and I'm going to start a new page here because it looks like I'm about out of room. And we got f of x is equal to x over the absolute value of x. And we want to find f of r squared. Again, it's always the same. You go through, and everywhere you have an x, you put in parentheses. Everything else remains the same. In this particular problem, we're plugging in r squared, so I plug it in where we put parentheses. So this is r squared, and this is r squared. Sometimes the parentheses don't help at all. In this one, the parentheses on top aren't doing anything. Parentheses on the bottom aren't doing anything. Now people have trouble simplifying this. They don't know how to go, where to go to from here. If you think what the purpose of absolute value is, it makes whatever is inside positive, or it could be equal to 0. But makes it positive. Let's focus on that. Well, what does that r squared do? Well, if I take negative 2 and square it, that gives us a positive 4. If I take 2 and square it, that also gives us a positive 4. So no matter what, when you square something, it's positive. So those absolute value bars aren't necessary, so we can just drop them. And then r squared over r squared is 1. And that's our answer. Now we have another way to determine if something's a function or not. It's called the vertical line test. And it says, if any vertical line intersects the graph at 2 or more places, it is not a function. So if any vertical line intersects a graph at two or more places, it is not a function. And let's look at some pictures. Got this picture here. Question is, can I draw a vertical line somewhere that will intersect at two or more places? Well, I can drop one right here that will definitely intersect at two or more places. So this one is not a function. Let's look at this one. Got this graph here. Question is, can I drop a vertical line that intersects at two or more places? Well, I drop one here, intersects one place. Drop one here, one place. Drop one here, one place. No matter where I drop a vertical line, the most it'll intersect is one place. So this is a function. Next one's an oddball line. Normally lines are always functions. Looking like this. There's one place I can drop a vertical line that causes a problem. If I drop it right on top of this one, it actually intersects in a lot of different places, specifically an infinite number of places, which is definitely two or more. So that's not a function. Now that one right there is actually our graph x is equal to a number. So that's why we had that in our list of the what you can't have. Now these next problems revolve around this idea right here, our function notation. Say we got f of x is equal to 3. Well, we're going to look at what's inside the parentheses, just what's inside the parentheses, and then we'll look at the other side also. Now one of these is going to be x and one of these is going to be y, and sometimes I ask this in class and people get it wrong. I say there's no trick. Well, if I look at this side, what's inside the parentheses is x, so this is our x, and so this must be our y. So keep that in mind as we look at these next problems. Okay. Actually, maybe I can write. No, I can't write on that. Okay. So we're trying to find what f of 0 is. Number 17. Now, we're trying to find out what that is, so this is like question mark right here. Now, again, whatever's inside the parentheses is going to be our x. So they're telling us x is equal to 0, and they're trying to find what y is. Well, I go to where my graph exists at x equals 0. So here's x equals 0, and I have to go up and find my graph here. So if I come up here, this is where my graph exists. My y value there is 4. So my answer would be 4. So again, we're trying to look at the point where the graph exists. So they give you x equals 0, so you go up there, and then you just write down the y value. Okay, let's look at our next one. F of 1. Again, what's inside the parentheses is our x, so they're telling us x is 1, and they're wondering, okay, what is the y value at x equals 1? So I go to x equals 1 where my graph exists, and it actually crosses at 1. The y value right there is 0. So that would be your answer. Now our last one. These last two ask us some very specific questions, but this one we want to find f of 2. And again, what's inside the parentheses are x, so they're saying x is equal to 2, and we're wondering what y is equal to at that point. So I go to where x is equal to 2, and I have to actually go down and find my graph here. So I go down, and here's where my graph exists at x equals 2, and if I go over, my y value is -4. So that'd be my answer. Let's start a new page here. I was just going to say, I'm surprised my tablet hasn't blown up, but here it goes and blows up, so I bring up a new one. Okay, this is our next problem. It says use graph to determine the function's domain. Now your domain is your x values where the graph exists. So your domain is your x values where a graph exists. If I look at this, I go to x equals 2. Well, I can go up and find my graph there, so it exists there. If I go over to -1, I can go down and I have to go off my graph, but eventually I'll find it. If I go over to -50 and I go down far enough, I'll find my graph, because this is slowly, as it's going to the left, it's slow, or as it's going down, it's slowly going to the left. Now, as it's going to the down over here, it's slowly going to the right. So it'll actually encompass all of our x values. So our domain is -infinity to +infinity. Now, next thing it asks for is your range. This is the y values where the graph exists. Now look at this. I see my graph exists at y is equal to 1. I can go over and find my graph. But if I come up to y is equal to 2, I cannot go left or right and find my graph anywhere. My graph doesn't exist up at 2. The highest y value where it exists is 1. And then it goes down forever, so it's going to -infinity. So this will go from -infinity to 1. Parentheses on -infinity, bracket on the 1. Now, infinities always have parentheses on them. We'll talk more about the bracket in the next problem, but basically, if you don't have an open circle anywhere, there's going to be a bracket. Now, C is our x-intercept. This is where it touches or crosses the x-axis. So as I look at this, it looks like it's crossing at 1 and 3. So our x-intercepts would be 1 or 3, or if you want to write those in point form, that'd be 1, 0, and 3, 0. Then we'll want to find the y-intercept. And this is where it touches or crosses the y-axis. This one looks like it's crossing at -3, so our answer would be -3, or if you want to write it in point form, it'd be 0, -3. And those would be my answers for that particular problem. Let's look at one more. Okay, first step, find a domain. Domain is your x values where your graph exists. If I look at the leftmost x value where my graph exists, this closed dot means it ends there. It doesn't go on forever. So the leftmost where it exists is -3. Now the rightmost x value where it exists, if I come to x equals 1, if I go up or down, I don't find my graph anywhere. It's at x equals 0, which is our y-axis, where it stops. So it goes to 0. Now notice over here at the -3, it's a closed dot, which means it includes that point, so I put a bracket. Over here at x equals 0, it's an open dot. It means it doesn't include that point, so we put a parentheses. Now our range. Let me grab a drink first. I'm getting parched. Okay, so our range. We're looking for our lowest y value where our graph exists. Well, the lowest one looks like -3. That's my lowest point of my graph. So it's going to go from -3. And then we're looking for the highest y value where our graph exists, which looks like 1. So it's going up to 1. Now down here at -3, I put a dot there just to really emphasize it, but there was no open dot. If you don't got an open circle there, then it's assumed to be just a filled in solid dot. So it includes that point. Up here at 1, it also includes that point. Now C, our x-intercepts, where it touches or crosses the x-axis. Now this isn't perfect. Maybe -2.8. Or if you want to write it in point form, it'd be -2.8, comma 0. It's, maybe -2.9, -2.7. A lot of times when you're finding the intercepts by hand, and you're not using some kind of technology or using algebraic methods, then you just kind of guess. A lot of people get the y-intercept wrong on this one. Our y-intercept is where it touches or crosses the x-axis. Open circle means it doesn't include that point, so it actually never gets to our y-intercept. So on this particular one, there is no y-intercept. And that's actually the end of that section, so we're done with that recording.